Well, sorry for being late. I would have already uploaded this yesterday, but I couldn't. So, we are starting off with our fifth class, and this one is a very important class because this particular topic is very important, and also there will be questions coming. Means probably there will be questions coming from this topic. And today we are going to discuss partial fractions, which are, let me tell you at the beginning that the problems involved in this particular topic are really big, huge, and we have to go through the problems a little bit, carefully. So let us understand what is partial fraction and why do we need them. So the idea of partial fraction, by the word, it is clear that if we have a function which we want to integrate, and it is in the form of rational function. Rational function means it is a ratio of two polynomials. That is called a rational function. So if polynomial or anything that can be reduced to a polynomial, so that is called a rational function. So if we have any rational function which I want to integrate, it may not be possible right directly. So in that case, what we want to do, we want to break it down into smaller rational functions so that it is easy to integrate. So the idea of breaking a rational function into smaller rational function, that is where we require partial fraction. Now, in this case of partial fraction, or what we do in partial fraction, we try to factorize the denominator. It is very much important that we first factorize the denominator, and depending upon whatever the factors the denominator have, according to that the partial fractions will be decomposed. That's how we do it. Next, let us understand that before going into the examples, when we can apply the partial fraction. Now, remember that if I am having a rational function, and in the rational function the numerator is having a greater power than the denominator, or greater degree than the denominator, then we can't use partial fraction. To use partial fraction, we must have the numerator function or the numerator polynomial which is of lower degree than that of the strictly lower degree, not even equal, lower degree than that of the denominator. Then only we can make use of partial fraction. If we have the numerator of higher degree than that of the denominator, then we must write the function in the form something like this, where we have taken out a factor which is greater than that of the denominator, which is making the numerator greater than that of the denominator, and the rest of the term which is left out, that must be of degree less than that of the denominator. Then only we can apply partial fraction. So remember this: if I am having any function which is having a higher degree than that of the denominator, I must try to manipulate it in some way so that the numerator must be having a lesser degree. So this is pretty much like your fractions, if you remember. So if I'm having a fraction p by q where p is less than q, then I call this as the proper fraction. If p becomes greater than q, then we call it improper fraction, but we know that any improper fraction can be written in the form of mixed fraction. So when I am writing it in the form of mixed fraction, say I am writing it in the form of something like this, a r by q. Then a is the whole number which is coming outside, r is the remaining portion, and q is the denominator. But we know that in mixed fraction r will always be less than q. So this is pretty much what we are applying in case of partial fraction as well. If we are having a proper partial fraction, I mean proper rational function, that is the numerator having lower degree than that of denominator, we can directly proceed with partial fraction. But if we are having an improper rational function where the numerator degree is greater than denominator degree, then I have to take out a factor and make the numerator of lower degree than that of denominator. Fine. So now let us move to the different types of partial fraction that we have. The first one being non-repeated linear factors. So if we see that the denominator of a rational function is having non-repeated linear factors, something like this, x minus a, x minus b, it can go on up to x minus anything. So in that case, what we do, we divide the rational function into constituent partial fraction, where the numerator of the partial fraction, each partial fraction will be a constant, something like this. So if I would have had more than one, so if I would have had, say, x minus a, x minus b, x minus c, so if this is px plus q, doesn't matter what, then I would have taken capital A by x minus a, capital B by x minus b plus capital C by x minus c, and so on. So if I am having linear factors, non-repeated linear factors, that means all the factors are different, in that case I can divide this whole rational function into partial fractions like this. Fine. Then repeated linear factors is if I am having any single factor which is repeated or repeated more than once in the denominator. So in that case, what to do, if I am having square of a linear factor, then I must take once alone and then again along with the square. So if I am having cube, then I will take once alone, then once with square, then once with cube, something like that. So that's how it goes on. And obviously this x minus b is standalone, so it will come as it is. So that's it. This is called the repeated linear factors. Then the next one and the last one, if we have irreducible quadratic factors. Irreducible quadratic factor means if I am having a quadratic term which can't be divided into linear factors, in that case what to do? If let us take this x square plus bx plus c, which is irreducible. Irreducible means it can't be broken down into linear factors. In that case, we take bx plus c, or a linear term, at the numerator of the partial fraction. Fine. So these are the three different types of partial fraction that we have. So we have to keep in mind that how to work with partial fraction, and let us now move to the problems. First one, simple problem, integration dx by x plus 1 into x plus 2. So here I have taken the first example where it is non-repeated linear factors. Non-repeated linear factors will be the most easiest one to solve. So we will start with what? 1 by x plus 1 into x plus 2, and that we can write as a by x plus 1 plus b by x plus 2. Now remember this, it is not necessary that we have to apply partial fraction always. If we can solve it with inspection, by inspection if we can solve it, in that case it is always better to avoid partial fraction, because partial fraction calculation is always, it is cumbersome, because it gives you so many equations to solve, and it may sometimes you may confuse and you may make mistakes. So by inspection, let me first show you how to do it by inspection. So if I'm taking this one, so this is 1 by x plus 1 x plus 2. So see here, this one I can write this as x plus 2 minus x plus 1. See, can I write this or not? I can directly write this. Now this is x plus 1, x plus 2. So from here, I can see, if I just separate the terms out, I can write it something like 1 by x minus 2, x plus 1. X plus 1 minus 1 by x plus 2. I can write this. See? So this 1 is becoming your A and this minus 1 is becoming your B. So see, in very simple steps I can solve this. So it is not necessary that in all problems you will be able to do it by inspection. By just looking at the given problem, you may not be able to find it. So in that case, using partial fraction is the safest way, because you will never make a mistake if you have done the correct calculation. But if you can do it by inspection, then always try doing it by inspection, because that will be helpful to avoid all those equations and all those complicated things that partial fraction brings into the problem, because solving a partial fraction in itself is a problem. So anyway, so this is how you do with inspection. And if it is not possible to do it with inspection, then let us see how to do it using partial fraction. So you have written it something like this. So now the next job will be to take LCM on the right hand side. So after you have taken LCM on the right hand side, you get something like this: a into x plus 2 plus b into x plus 1. Now let us take the terms containing x, separate the terms containing, or terms does not containing which is not containing x separately. So it is something like this. So x plus 1 into x plus 2, they are both common in the denominator, so they get cancelled out. Now you see, on the left hand side there is no term involved with x, so therefore the coefficient of x is 0. So therefore I can write a plus b as 0, and obviously on the left hand side there is only 1, so therefore the constant term is 1, so therefore I can write 2a plus b is 1. So I get these two equations. Now obviously solving these two equations, we get a as 1 and b as minus 1. That is something which we actually found out by inspection only. So for this problem, doing the inspection is easy, but for other problems it may not be. So now definitely I can write dx by x plus 1 into x plus 2 as dx by x plus 1 minus dx by x plus 2. Integrating, it becomes log of x plus 1 minus log of x plus 2, both inside mod. And so from here I can write log of mod of x plus 1 by x plus 2 plus c. Right? Simple problem. Now this is just a beginner's level problem. In exam they are not going to give you such problem. So let us take it to the next level. Number 2. Integration of x square plus 1 by x square minus 5x plus 6. Now before we start doing it, you can see that x square plus 1 is having a degree 2 and x square minus 5x plus 6 is also having a degree 2. So I can't directly apply partial fraction on this. So in such case, what we have to do, we have to ensure that we take out a factor so that the degree in the numerator becomes less. So what to do? I am adding a 5x, subtracting a 5x, I'm adding a 6 and subtracting a 6. So basically what I'm trying to do, trying to take out a factor of 1. So you see, if I have taken this x square minus 5x plus 6 out, then it becomes 1. So that part is this. And you are left with plus 5x minus 6 plus 1. So that is 5x minus 5. So that is the other part. So now the numerator has become less than 1. The numerator degree has become less than the degree of denominator. So therefore, now we can make use of partial fraction. So for doing so, what we will be doing, we will be trying to apply this. So x minus 1 by x minus 2 into x minus 3, that is a by x minus 2 plus b by x minus 3. So once again, our job will be to take LCM. After taking LCM, our job will be to collect the terms containing x and the terms not containing x. Then a plus b here will become 1 and 3a plus 2b will become also 1. Now after solving, a is coming out to be minus 1, b is coming out to be 2. So therefore, I can separate out the integration something like this. And then after integrating, we have our answer. Go through the problem. In this problem, the key part is solving these equations and forming this partial fraction, because after you have got the value of a, b and all, then the integration becomes very easy. So there is nothing much left for the integration, but solving this partial fraction becomes a little bit difficult. Now let us move to the third problem. Number 3, I am having 5x by x plus 1 into x square plus 9. Now once again, here you see the numerator degree is less than the denominator degree, so no problem with that. But denominator is having a term which is quadratic and it is irreducible. Irreducible means I can't break this into constituent factors, linear factors. X square plus 9 can't be broken into linear factors. And obviously, if you just go into complex number, it can be, but as we are talking about integration which is involving real numbers only, so we can't do that. So in case of bounding ourselves to real number, x square plus 9 is irreducible, it can be factorized. So therefore, we have to do what? We have to take a quadratic factor, that is x square plus 9, and the partial fraction will be bx plus c. Now again, let us take LCM and do whatever the necessary work we have to do. So after taking LCM, we get this. Now collect the terms containing x square, x and the constant term. This is how it looks like. So from here I can see on the left hand side there is no x square term, so therefore a plus b is 0. Now x containing term, there is 5x, so b plus c is 5, and again there is no your constant term, so therefore 9a plus c is equals to 0. Fine. So therefore a is minus half, b is half, c is 9 by 2. Just solve and you will find out. Then our integration becomes something like this. So minus half integration dx by x plus 1 and half into integration x plus 9 by x square plus 9 dx. So the first one will be easy. It will be minus half log of mod of x plus 1. Then separating out half of integration x by x square plus 9 and then 9 by 2 integration of dx by x square plus 9. So these are simple integration. Once you solve it, you get this as your answer. So I am leaving the integration part to you. I am not showing all the steps of integration. So please ensure you do it yourself and understand what is happening. But I am more interested in showing you the steps involving the partial fraction, so I am doing it. Next, number 4. Number 4, I have integration dx by x plus 1 whole square into x square plus 1. So this one is having a repeated linear factor as well as a irreducible quadratic factor. So I have got everything in it. So what to do? For 1 by x plus 1 whole square, this is a repeated linear factor, so I have to take these two. That is a by x plus 1 plus b by x plus 1 whole square. And for x square plus 1, as it is a irreducible quadratic factor, I have to take this. Fine. Now the next job is to take LCM. Now taking LCM is going to be a little bit cumbersome, but be patient, do it carefully, you will be able to. Now once again, if you can do it without doing this partial fraction step, if you can do it by inspection, then it's very good, but otherwise doing it through partial fraction is always safe. Now my job will be to collect all the terms containing x cube, x square, x and constant term. So this is what you get. On the left hand side you have 1, on the right hand side you have this whole thing. Now be patient in clubbing all the terms together. Now, so from here I can see there is no x cube term on the left hand side, so a plus c will be 0. Then again no x square term, so this whole thing will be 0. No x term also, so a plus c plus 2d also will be 0. Only there is a constant term which is 1, so therefore a plus b plus d, that will be 1. Right? So now the next step is to solve and find the value of a, b, c, d. Now carefully, if we solve, you get a as half, b as half, c as minus half, d as 0. Now let me just give you an idea how to solve it. See here, we can do it very simply like this. A plus c, this is 0. And here a plus c plus 2d is there. So a plus c becoming 0, so that means 2d is 0. So from here I get d equals to 0. Right? Now if d is 0, from here I can see a plus b is becoming 1. Now come to this big one, a plus b plus 2c plus d. So from here d is 0, so d is cancelled. A plus b is 1, so from here I can write a plus b as 1. So therefore 2c is becoming minus 1, so c is becoming minus half. So once you get one value, you already got the value of d, from here you got the value of c. Now put it anywhere and then you can find the values of other variables. So this is like you just go on putting and matching values, and from there you can solve and find the solutions. Fine. Now next, once we have this, then our integration becomes something like this: half of dx by x plus 1 plus half of dx by x plus 1 whole square minus half of integration x by x square plus 1. So do the integration. This is what your integration comes out to be, and that is only your answer. Now obviously these are very small integrations, you need not go on showing too many steps, because by now all those general integration formula, substitution formula, otherwise if that is a very key important substitution, you can directly do it, no issues. Number 5. This is the last problem, and this is a very, very important problem, in the sense this problem is a very typical problem, and which will give you an idea how to solve a problem without using partial fraction. So let me just take you through the steps where we can use the partial fraction. Then I will show you a different method where we do not need any partial fraction. So x to the power 4 plus 1, this can be written as x square plus 1 whole square minus 2x square. So therefore I can write this as x square plus root 2x plus 1 into x square minus root 2x plus 1. I can write this. So therefore integration of dx by x to the power 4 plus 1 can be written as this: x square plus root 2x plus 1 into x square minus root 2x plus 1. From here you can make use of the partial fraction. This is one irreducible quadratic factor, this is one irreducible quadratic factor. So from here you can take ax plus b by this plus cx plus d by this, and then you can go on solving to find the values of a, b, c, d, and then solve it. But that is a very cumbersome and very difficult process. So instead of going that way, what we will do, we will apply a small trick, and that particular trick, if you can master it, then definitely these problems will become very easy. So let us start. What we have done, I have multiplied a half and then a 2, right? Next, I will be writing this 2 as 1 plus x square plus 1 minus x square. So this is the trick that which we need to apply. Once I have done so, I will separate out the integrals. I will separate out the integral something like this. So half into 1 plus x square by x to the power 4 plus 1, and half into 1 minus x square by x to the power 4 plus 1. Next job will be to divide by x square both in the numerator and denominator. So if we do that, this is what we get. Now obviously here there will be a change of sign, because if I divide by x square, it will be 1 by x square minus 1, but we want it 1 minus 1 by x square, so there will be a negative sign coming in. Now in the next step, see here, this x square plus 1 by x square can be written as x minus 1 by x whole square plus 2, and also here I can write this as x plus 1 by x whole square minus 2, right? So x minus 1 by x, if I take this as z, then 1 plus 1 by x square dx, this becomes dz. So therefore I already have the dz at the top. Then if I take here x plus 1 by x as some t, then 1 minus 1 by x square dx becomes dt. So see how simple it is becoming. No partial fraction required. You will be able to solve this problem without partial fraction only. So that's how simple it is. Then, so our integration reduces down to half of dz by z square plus 2 minus half of dt by t square minus 2. So z square plus 2 is 1 by root 2 tan inverse z by root 2, and dt by t square minus 2, that is 1 by 2 root 2 log of mod of t minus root 2 by t plus root 2 plus c. Now let us put back the values of z and t and calculate. If we do so, we get this as your answer. So this problem, it can be solved in various ways, but this is the shortest way of solving. If you try solving using partial fraction, then it can it can just take you ages to solve. Now there is another problem which I am just writing here. You can try solving, that is integration root over of tan x dx or integration root over of cot x dx, whichever one you can solve it, or integration root over of cot x dx. Similar problem, integration root over of cot x dx or integration root over of tan x dx, they will be solved in this particular method only. They will give you a partial fraction, but if you try doing it using partial fraction, then it will take you really long time. The whole problem will become very big. But if you try applying this technique, you will see that it is becoming very easy to solve. Anyway, so that's it. That is our class. We will meet maybe in coming Tuesday. Thank you.